Random variables of a probability experiment. All probability experiments have variables. In the experiment, flip a coin twice. The two possible variables are the number of heads in the two flips or the number of tails in the two flips. When we denote variables for probability experiments, we use the capital letter X. They're called random variables because they are the result of a random probability experiment. That's the result of a chance happening. So let's take a look at an example. So if we have a variable that we are using the number of heads for two flips of the coin, let's conduct the experiment, 2 coin flips, 3 different times and examine the results. So let's suppose we flip the coin twice, and that's the first run of the experiment, flipping the coin twice, and we realize that we didn't get any heads. So we got 0 heads. That would mean that we got 2 tails. The value of the variable would be 0. Okay, so if we get 2 tails in 2 flips of the coin, and our variable x represents the number of heads, then in this run of the experiment, x would be 0 because we got no heads in this experiment. So we write x equals 0. Another time we run the experiment, we may find that we get 1 head, and therefore the other one was a tail. So in this case, the value of the variable number of heads is 1, and so we assign 1 to x because we got 1 head. And if we run the experiment a third time, we may get 2 heads. Heads on both tosses, and therefore the value of the variable is 2, and so we assign the value of 2 to the variable x. So we ran this experiment 3 times, and each time we got a variable number of heads. The first time we got 0 heads, the second time we got 1 head, and the third time we got 2 heads. Consider the fact that there are only 2 coins. Is there any way for x to be any number other than 0, 1, or 2? For example, can x be 3? Or can x be a negative number? And the answer to that question is no. X is isolated to the values of 0, 1, and 2 because we are only flipping the coin twice, and therefore the maximum number of heads we can get is 2, and the minimum number of heads we can get is 0. So all the possible values for the variable x are 0, 1, and 2. So since the values of the number of heads variable are discrete values, 0, 1, and 2, the variable is called a discrete random variable. There are also continuous random variables for probability experiments in which the variable values are continuous, and we're going to cover those in the next chapter. After noting the possible values of a discrete random variable, we can create a probability distribution table and histogram. So once we've established that the values of x for this experiment, flipping a coin twice, are 0, 1, and 2, we take those values of x and we create a probability distribution table, and from that we can create a probability histogram. So the probability distribution table has less columns than a frequency distribution table that we saw earlier in the course. The probability distribution table for the discrete random variable number of heads in 2 tosses of a coin remember that we built this tree diagram earlier. There are 4 outcomes for 2 tosses of a coin, and these were the 4 outcomes. You can get 2 heads, you can get heads and tails, tails and heads, or tails and tails. So noting that we have 4 outcomes, these 4 outcomes are going to help us establish the values for the probabilities. So in building the probability distribution table, there are 2 columns. The first column is number of heads, That is the variable that we're examining in this experiment. And the second column is probability. So number of heads is denoted by the capital letter X, and probability is denoted by a capital P, and in parentheses we're going to put X because in this column we're going to label the probability of getting that particular value of X. So in the first column, number of heads, you list the possible values of X that we established earlier. When you flip a coin twice, the minimum number of heads that are possible are 0, and the maximum number of heads that are possible are 2. There could be no more. So we list all of those possible values of X in a column, in the first column underneath the letter X. Now in the second column, we try to determine what is the probability of that value of X occurring in this experiment. So if X is 0, what's the probability of getting 0 heads? If these are our 4 outcomes, the probability of getting 0 heads is getting 2 tails, which is 1 out of 4. So we would label that probability 1 out of 4, or 0.25, or 25% in this column for probability. And then the next row, we would figure out the probability of getting 1 head. So we would look at our outcomes from the tree diagram, and we would note that there are 2 out of 4 outcomes where there's exactly 1 head, and therefore 2 out of 4 is 50%, or 1/2. And then the last value of X has a value of 2. The probability of getting exactly 2 heads we're going to put right here, and that would be 1, because there's an HH here, there's only one of them, 1 out of 4, or 0.25. Okay, so these are our 3 probabilities for our 3 possible values of X, and that's how we build a probability distribution table. These 3 probabilities could be written as fractions, 1/4, 1/2, and 1/4, or as percents, 25%, 50%, and 25%. But you'll be told exactly how to write your probability distribution tables in your graded work. So once you have a probability distribution table, we can produce a histogram off of this. One thing to note is that that last column, P of X, has a sum of 1, and it will always have a sum of 1. So if you add 0.25 plus 0.5 plus 0.25, you will get exactly 1. So that's how you can check if your probability distribution table has been created properly. Sum up the values in the second column and make sure that they equal 1. So our histogram for the experiment 2 tosses of a fair coin looks like this, and this is how we build it. We make a horizontal axis, and we label the values of X on the horizontal axis. Now we've established our values of X are 0, 1, and 2, no more, no less, so we just put those values of X on the horizontal, and X represents the number of heads in this experiment. The vertical axis is P of X, that's the probability. And there are 2 basic probabilities in our table, 0.25 and 0.5. In other more complex tables, we may have more varying probabilities in the second column, but for this example, it's pretty simple. There's just 0.25 and 0.5, and we build histogram rectangles where the value of X is centered beneath each rectangle, and the height of the rectangle is the same as the probability of that value of X. So for X equals 0, P of X was 0.25, and for X equal 1, P of X was 0.50, and for X equal 2, P of X is 0.25 again. Okay, so one of the things to remember is that the values of X are centered in the middle of each histogram bar. and the height represents the probability. So by looking at this histogram, you could answer a question. I could ask, what's the probability of getting no heads on 2 tosses of a coin? No heads means 0 heads. So come here and you look at the height of the bar, and it would be 0.25. That is the probability. So this is our probability distribution table complete, and here's our probability histogram complete, and let's answer some questions. What's the probability of getting at least 1 head in 2 coin flips? So we go down to, we can either look at our distribution table or our histogram. At least 1 represents the numbers 1 and 2. So for x equal 1 and x equal 2, at least 1 would be the sum of the probabilities for p of 1 and p of 2. So we would add 0.5 and 0.25, and that would be our answer, 0.75. The probability of getting at least 1 head is 0.75. Again, we could do it with the histogram. We would add up the sum of the bar for x equal 1 and the bar for x equal 2. 0.5 plus 0.25 is 0.75. Okay, so whenever you have a question involving the words at least or at most, or less than or more than, it's going to probably involve the sum of multiple probabilities because it refers to multiple values of x. So the probability of at least 1 refers to p of x equal 1 and p of x equal 2, and that requires you to sum up those two probabilities. So let's do this one. What's the probability of getting less than 1 head? Well, less than 1 represents the number 0. There is no other number that is less than 1 in this probability distribution table. So the probability of getting less than 1 just refers to a value of x equals 0. There's no summing that you need to do, no adding. The answer would just be 0.25 or 25%.